Alright, welcome to the beginning of the rational functions unit. Let's go back a step and ask ourselves, what is a rational function? What we have here, we're going to look at it in two of the four faces. We're going to look at it in the equation form and the graph form. So right here I give you an example of a ruler / equation that is a rational function. We have y equals 1 over x minus 1. Before we even get to that, what makes this a rational function is, and you answer that. Pause the video for a second, try to answer what you think a rational function is. Okay, welcome back. If you answered that a rational function is an equation where it is a fraction, and in the denominator there is the variable, or a variable, or several variables. So a fraction alone does not make it a rational function. The fact that the variable is in the denominator, that's what makes it a rational function. And what's interesting about that is, of course, we never want to, well, we don't never want to, but if you divide by 0, that's an interesting scenario. So if our rational function ends up being something like 1 over 0, then that's undefined. You get no answer. You get no output there. So if we have our denominator equal 0, we have an undefined scenario. So what happens is we want to check that out. We want to set our x minus 1 in this case equal to 0 to find out if we'll get an undefined answer. We move our 1 to the other side and we get x equal to 1. So whenever x is equal to 1, it will make our equation, in this case y equals 1 over x minus 1, it'll make it undefined. What that means, bam, is we get an asymptote, and x, what we write is x cannot be equal to -1. So if you put, wait, what did I put? Oh, oops, equation is undefined. Ooh, I gotta add that. I have a mistake in there. That is actually supposed to be a +1. So let's make that +1. X cannot be equal to +1. Okay, so x cannot be equal to +1. Bam, let's move back. What that means is, oops, let's move that back a little bit. Sorry about this, let me fix that. Bam. What that means is we draw an asymptote. We draw an asymptote at x equal to +1. Bam. We draw this dotted line here. It's not a, oops. Never mind that. Okay, so this asymptote here, that dotted line right there tells us we have no answer there. So we draw the dotted line to tell us don't draw the graph over there. So it's like a wall in essence that our graph should not cross over. Okay, so now we draw our function according to that. So let's draw this. Our graph will be, if we remember how a rational function looks like, there are two parts. It asymptotes with the x-axis, curves down, and asymptotes with the x equals +1 in this case. So the left hand side is below the x-axis, because if we plug in points it's going to give us negative numbers all the time. And then on the other side of our asymptote we begin again. It gets close, whoops, let's read, but it never touches our asymptotes. In this case we have x-axis as an asymptote, and we get the x equals 1 as another asymptote. So there's a lot of nuances with this, a lot of little details. In general here we should know what the equation is and how the graph should look for a basic rational function. Okay, and now we always have to look for the asymptote. When is our denominator going to equal 0? It is also called the excluded value. So you will see that in the next few videos be called the excluded value or values. Okay? Alright, thank you very much. We'll see you all in the next video.